Let's get started. I would like to introduce KYZEN's Regional Manager, Barry Thomas.
Well, good morning, Sherry, and thank you for allowing me to participate in KYZEN's Tech to Tech webinar today. Before we begin, I would like to thank the audience for taking time from their busy schedule to be with us this morning. So thank you. As Sherry stated earlier, my name is Barry Thomas. I'm KYZEN's Regional Sales Manager for the Midwest Territory. My responsibilities include the electronics and industrial sector. Today, I will be focusing on the industrial industry, more specifically on remanufacturing and the cleaning process, and which one is right for you. When I think of remanufacturing, I think of recovery, rebuilding, recycling. I even think in terms of how we as citizens can be good stewards of the environment and how we can save precious resources. But the lion's share of remanufacturing is in the automotive sector. Their definition of remanufacturing is the rebuilding of a product to specifications of the original manufactured product using a combination of reused and repaired parts. Remanufacturing requires the repair or replacement of worn out or obsolete components and modules, parts that are subject to degradation, affecting the performance or the expected life of the whole are replaced. A remanufactured machine should match the same customer expectations and performance as new machines. A reasonable question to ask at this point might be, well, Barry, what's the difference between repair versus remanufacturing? Well, repair is only taking care of the part that is broken. Remanufacturing drills down a little bit deeper and is more comprehensive. Remanufacturing starts with research. Remanufacturing process starts with completely rebuilding the unit. And remanufacturing is replacing everything that could potentially break in the lifetime of the unit. Here are some examples of automotive remanufacturing applications that I see every day. They include motors and transmissions, air conditioning compressors, alternators, electrical and fuel systems, brakes and cooling systems as well. There's a myriad of components, too numerous to name and put into this presentation. Here are some real live examples of photos that I had taken in my travels to industry, just to give you an example of what we're looking at. Now that we're considering getting into the remanufacturing process, or perhaps we're already knee-deep into the process, we may be asking ourselves, how do I pick the right process? How do I choose the correct chemistry? Well, there are a few questions that need to be answered that will dictate what equipment and what chemistry will be best for the application. We always start by asking ourselves, what metals will I be cleaning? Will it be steel, aluminum, brass, etc.? Will it be an aqueous process or a solvent process? If so, will it be spray and air, immersion, or a combination of the two? Will the soil to be removed need to be done utilizing ultrasonics? Next, what cleaning chemistries will I choose? Well, you need to ensure the chemistry is employee safe, but also environmentally safe. You'll want a formula to be multi-metal safe, as well as formulated to extend bath life. Next question you want to ask yourself, will I need a corrosion preventative material at some point in the remanufacturing process? These are a few of the questions that you should examine before purchasing equipment or choosing a chemistry. The next few slides will focus on equipment and processes that I encounter every day in the field. This is a typical 4 cleaning stage process, and I'm selecting steel. Steel by itself is a unique metal from the standpoint that it has a propensity to rust. As such, it needs to be treated differently. If you look at the left side of the slide, you will see that it's a spray application using an aqueous chemistry. The next stage is in a rinse, followed by the next step being an immersion process. And this is where we would use an acidic stripper to remove the oxide and the carbon. A typical acid stripper would be a mild citric acid or perhaps a phosphoric acid. Those two seem to work real well at the removal of rust. Finally, we go into a final rinse, and this is where you can either select to use an RP, rust preventative material, or corrosion protection material at this stage. Next is a 4-stage remanufacturing cleaning process for aluminum. You'll notice it resembles the previous slide. The difference, we're using an aqueous chemistry from start to finish. I will caution you, when you're using an aqueous chemistry in a spray application, you'll want to make sure that it's designed for spray. Otherwise, you will have excess foam, not only in the bath, but possibly on your floor. Although it'll be a great cleaner for your floor, I'm not sure that's the objective you're trying to achieve. Again, it follows the same process from spray to rinse to an immersion process where you can either use ultrasonics or not, followed by a rinse. And again, you can elect to use a corrosion protective material or not. Here's an example of some customer parts of mine up in Michigan. They are a remanufacturer of diesel parts for the heavy-duty industrial trucking industry. They utilize a multi-stage cleaning process. Basically, it's a 6-stage multi-stage cleaning process. If you look at the top of this slide, you'll see a bath that holds approximately 125 gallons of solution. In that tank is an aqueous chemistry running approximately 12% concentration. The parts are in a basket. They get submerged into the tank and it runs for 90 seconds. The parts lift and traverse into tank number 5. Tank number 5 utilizes the same recipe with the exception the chemistry is diluted to 10%. Same recipe, parts lift and traverse over to tank number 4. This process continues until it gets to tank number 1, where ultimately the solution is down to 1%, effectively acting as a rinsing agent. Finally, we have an optional pre-cleaning process. This is a process that utilizes vacuum degreasing. Vacuum degreasing is a technology that's been around for many, many years. It's just starting to gain some traction and momentum in the remanufacturing space. If you're interested in vacuum degreasing, perhaps we'll have a tech-to-tech session going forward. But if not, I'd be happy to supply you with some information. At the end of this presentation, feel free to give me a call or shoot me an email. My contact information will be made available. In a nutshell, or the Cliff Note version, I like to say, vacuum degreasing is a fully self-contained, airtight cleaning system that uses either a hydrocarbon or a modified alcohol as the solvent. There are many advantages to this technology. Most notably, the system uses 0 water. There's 0 detergent cost, 0 mixing, 0 disposal, and because of the footprint of the equipment, it uses very little energy for processing these parts. This system is designed to remove gross oils and grease and remove any loose soils. It'll follow the next process, similar to the previous slides we spoke about for steel and aluminum. We'll spray, we'll rinse, we'll use ultrasonics and immersion, and we'll finally rinse and use an RP if necessary. This slide is rather interesting to me. It's the upstream process after cleaning. It's bead blasting. Bead blasting is needed in order to take care of some of those stubborn soils that they're in the cavity or in the blind holes that just the chemistry and the aqueous system that we talked about just doesn't fully remove all of it. So it's necessary to have bead blasting. I will tell you, bead blasting is a time-consuming, tedious, and laborious process. It's the part of the process operators will dislike the most. In fact, there's probably more employee turnover at this stage than any other stage inside the plant. The takeaway here is, if we go ahead and we optimize our processes, we select the right chemistries. I have a customer that utilized the chemistries and the processes we spoke about and was able to take their parts that required approximately 25 minutes of bead blasting down to less than 5. This is a huge savings, not only from a labor standpoint, but the amount of consumable that they were spending has been reduced dramatically. At the end of the day, if we do things correctly, here are some of the tenacious soils that we're dealing with on the before, you will be able to achieve the after results. We see this every day in industry. In conclusion, hey, if you're in remanufacturing, it's no surprise to you. You deal with some of the most tenacious soils that you find in industry. The good news, with planning, proper equipment, coupled with process choices and proper chemistry, your ability to produce a quality remanufactured product increases dramatically. That ends my presentation. Thank you for your time. I'd like to turn it back over to Sherry.
Thank you, Barry. If you would like to discuss this topic further, please contact your local KYZEN regional manager or send an email to tech@kaizen.com, and we will have one of our cleaning experts schedule a follow-up with you as soon as possible. Again, we thank you all for joining us today, and we hope to see you again soon. Stay safe, stay healthy, and have a great day.